Hi guys, today we will show you how to solve this polynomial remainder problem. Our question says 2x to the power of 4 plus px cubed plus 5x squared plus 7. When it's divided by x plus 1, x minus 2, which is two divisors, it gives you the remainder of qx plus 18. This question asks you to find the values of p and q. So instead of using long division, we will use the remainder theorem, which is much faster. First, let us break down the problem. There is the polynomial, which is the function x. There is the divisor, which is x plus 1, x minus 2, and the remainder qx plus 18, and the values to find. So let us work with that. So how do we start this question? Concept 1 is substitution. So as there are two divisors in this equation, we need to substitute both divisors into the polynomial. However, you only can substitute one divisor at a time, or else it will not work. So just for an example, let's sub in the first x plus 1 into it. As x plus 1 is always 0, x is negative 1. So we sub in function x as function negative 1 into the equation. So the equation will be 2 bracket negative 1 to the power of 4 plus p negative 1 cubed plus 5 negative 1 square plus 7. And when you simplify this equation, you can use your calculator to simplify. It will give you 14 minus p. Now let us move on to the second divisor. As the second divisor is x minus 2, x will be equal to 2. So we sub in function x as function 2 into the equation. Then the equation will be 2 bracket 2 to the power of 4 plus p 2 cubed plus 5 2 square plus 7. And when you simplify that equation, it becomes 59 plus 8p. Now let's divert your attention back to the first equation. You may realize there is still the remainder. So since function negative 1 is equal to 14 minus p, and function negative 1 is also equals to the remainder qx plus 18, we can combine the equations as 14 minus p equals to qx plus 18. And now let's simplify it using your basic math knowledge, and you will get p minus q equals negative 4. Now let's look at the other equation. Function 2 is equal to 59 plus 8p. And since function 2 is equal to the remainder as well, 59 plus 8p is equals to qx plus 18. And when it's simplified and combined, it will be 8p minus 2q minus 41. And then now for the fun part. You might have learned simultaneous equations in secondary 2, so we're just gonna redo it all over again. Now we have two equations with two unknowns, p and q. We can sort it into equation 1 and equation 2. Equation 1 can be p minus q equals negative 4, and equation 2 can be 8p minus 2q equals negative 41. To create a constant value, in this case, let's use q. So we multiply equation 1 by 2 to create 2q that balances with equation 2, and name it as equation 3 as 2p minus 2q equals negative 8. Now on the final stretch, since the q in equation 2 and 3 are the same, we can subtract equation 3 from equation 2 to remove the constant q from the simultaneous equation. You learned this in secondary 2. So you will get 6p equals negative 33, so naturally p will be negative 5.5. Now we sub p equals 5.5 back into equation 1 to find q. Use your calculator and you will see that q equals to negative 1.5. It is that easy.